It's really a pleasure to be here to talk to you about these topics today. You'll find that today I'm going to come at you from the bottom up, which means the hardware. I've had the pleasure of seeing some other presentations earlier, and so a lot of them were, models and applications and benchmarking, and all that stuff's important to us too. We'll get into some of that, but today I would like to kind of give you a start with just kind of orienting us in something that I think a lot of us have heard a lot about, which is this large, almost immense scale build out of data centers basically for AI. And we can kind of look at these charts and say, well, what's going on here? Because these charts, which are recent charts from McKinsey Group, show that essentially out in 2030, only about less than 40% of the workloads are going to be Gen AI associated. And the rest of them, over 60%, would be normal workloads, right? So why so much of a big build out, right? And that's what the chart on the right says. Well, about 70% of data center power capacity, because this chart is measured in power, is going to be used for AI, right? And this is because AI tends to take a lot of power in order to be able to operate, and I think that's all intuitive to many of us who know in the hardware industry that GPUs typically back up a lot of that infrastructure. But here's a chart that helps me explain the more detailed story. Right? There is a detailed story that comes with this, because this is a chart that shows the spread or the pantheon of models from a parameter count perspective, right? So going from left to right, you got models that are less than 5 billion parameters, and then all the way over to the right, greater than 200 billion. And this is not a scientific chart necessarily, but it is an intuitive chart, empirically built, that says that, as we move up to scale of parameter count, the cost to run these things goes up. In fact, I was just sitting with the topic on analytics, I can't remember the guy's name, but he was basically had that data that showed this is exactly what happens when you put models that are trillions of parameters. It's very, very costly to run. So this is something that is really being examined by many people implementing practical AI today, because they're starting to move down the scale, right? Why? Because it's much cheaper to run those models. And so this is a situation where many, many, many models are now being created, which are experts, and we've heard mixture experts and things like that. These types of models are being used in agentic kind of use cases and many other cases where you're using multimodal models to do a lot more things with just smaller expert models. And so the volume of instances is really going up in this particular area, both for cost and also for convenience and accuracy. So on the lower end of the spectrum, these are models that can be run much more inexpensively through the use of things like CPUs. And so we'll talk a little bit more about how that really works using Ampere's CPUs. Ampere is a CPU manufacturing company. So why do we recalibrate for this Gen AI period? Because, as we said before, Gen AI requires a lot of power and therefore cooling, and it's creating a lot of sort of data center build out, very specific to that need. At scale, very expensive. So enough said on this, because essentially what we're going to talk about almost the rest of this talk is how to run AI a little bit less inexpensively and really kind of build out something that's scalable and very, very flexible. So data and data sovereignty, big concerns. We've heard a lot about that at this particular show today. And in Europe, as I've traveled around, talked to many people here, that is a big concern, and it's even a big concern in areas of Asia and whatnot. So as we look at the needs and the recalibration of getting to a better infrastructure for low cost or less expensive AI, these are big concerns. All right, so this morning, Scaleway announced a number of different things, and maybe stuck in there was Ampere. Ampere, this is an actual snapshot of the pricing table from Scaleway, and our instances are the COP ARM instances in Scaleway's infrastructure. You compare those instances, these are various sizes of instances, against the next closest competitor, which is an x86 instance, in this case an AMD EPYC instance, and you're going to see it's going to be priced about 20% less than those x86 instances. Now that's pretty cool, because actually what's not really necessarily known and put out there is that we outperform that instance. Yes, it's cheaper, and we outperform that instance by somewhere between 30 and 80%, depending on what benchmark you're talking about. And I'll show you some more benchmarks here in a moment. So if you add all that kind of value up, it's anywhere from 50% to almost 2x better in performance per euro. So great value now, just released by Scaleway today. Let's talk about performance, because performance actually makes a big difference. Here are some benchmarks of our processors, Ampere 1 processors, which have 192 cores, and those processors being benchmarked against an AMD EPYC processor. In this case, it's Genoa. And so that's a very good benchmark in the industry for processor performance. Now, performance per rack is our metric for showing performance for CPUs, taking into account the power efficiency. Why? Because power efficiency actually really, really matters. And when you have a rack, you have a certain power budget. And that power budget doesn't really change rack to rack inside of a data center typically, but between data centers it changes. And so to put performance per rack into perspective, you're taking into account the efficiency of the processor, because I can put more processors that are lower power into the same power budget and get more performance out of that rack. So it's just a measure of efficiency, really. But you can see here anywhere from 30 to almost 2x better performance at that rack level, meaning that we can put a lot more horsepower into a given power budget. And that goes across many, many different application areas. In here, we are showing a number of application areas that are more around cloud native operations. Nginx is a web front end, Redis, a key value store, Memcached, an object store, MySQL, of course, relational database, and then DLRM and Llama 3, obviously, are AI, right? So this is a picture of a modern AI-enabled digital service on one slide. And so you can see the efficiency kind of built into these processors. And that also translates now into bigger Gen AI models, right? One of the things that Ampere philosophically has done as we have built our roadmap and our products and differentiated from an x86 ecosystem that has traditionally been multi-threaded and has turbo and lots of big L3 caches and things like this, is we've said, look, we don't want to penalize anybody for power, right? Because power has always been one of our main value propositions, and we started this company 8 years ago, actually. We said, look, we are going to be about sustainable computing. And sustainable computing means I'm not going to take a bunch of power to do something that you don't need. And when we came out with the Ampere 1, which is our flagship product line, and this is a ground-up design. So we're a CPU company. We build CPUs. This is ground-up design, still ARM instruction set. But we said, look, of all those workloads I showed you earlier, 60% of these workloads in 2030 are going to be regular workloads. Of that 60%, pretty much 90 to 95% of them do not need extra memory bandwidth, right? Because they don't use it. Most traditional workloads do not use this memory bandwidth. So when we came up with our product roadmap, we said, we're not going to penalize people. by putting 12 channels of DDR5 memory into every product that we build. So Ampere 1M is our answer to that. It's a 12-channel platform that has a lot more memory bandwidth. And guess what? Memory bandwidth is absolutely really needed by Gen AI. It's probably one of the biggest parameters in determining performance of a hardware product. And if you look at GPUs, this is one of the reasons why they are so high performance, is because they have what's called HBM. So today I'm showing you Ampere 1M, which is being compared against, in this case, an L40S. Yes, I did a bait and switch. I was comparing to another processor just a moment ago on the 8-channel Ampere 1 product, Ampere 1M 12-channel product. I'm comparing against a GPU. Why? Because this is a specialized product for AI. And because we have that extra memory bandwidth, we can actually do a lot of AI with a CPU product. And so here we're showing against an L40S, which is a very typical adapter that you would find for inference, right? One of the things that we do is we look at these things and we say, well, we're going to show you how good we do with these typical smaller parameter count models, right? Here I'm showing 1 billion Llama 3 to 8 billion Llama 3. And I'm showing you both tokens per dollar and tokens per watt. And this is how much better they are than that one L40S. So you can kind of get a picture of how well these products do against GPUs. Okay, to actually really put a fine point on this, because performance per dollar is kind of measured on CapEx boundaries, right? What does it cost to purchase these things? Which, yes, the CPUs are less expensive typically. But here is operational cost. The way to read this chart is, again, I'm comparing against typical GPUs, and what I'm showing is how many models I can put on that platform simultaneously. Meaning I can run multiple small models on our CPU platform at once, and that is a huge value for these agentic type use cases where you're putting a lot of different models in succession or in parallel to create something that's reasoning or more complex from a use case perspective. And in this case, for 610 watts, I can put 96 models on that server if they're 1 billion models. And then you can see that kind of goes down as the parameter count goes up. Llama 8B, 32. But for GPUs, you're going to get one model in that GPU. That's it. And this is one of the reasons why, kind of, maybe it's actually a widely known fact to people who do run models a lot on the infrastructure, is that a GPU is kind of a sledgehammer. For a smaller model, you don't need it, right? So, but for larger models, over on the right side of this chart, you do need them because there's so many more parameters in those larger models. And it takes a lot more memory bandwidth and a lot more computational horsepower. But the piece that I really want you to take away from this is the operational cost. So you're seeing here $12 a year for that 1 billion parameter model versus maybe 831 per year, or all the way over 2,000 for an H100. This is the major factor in cost for this type of implementation. Okay, so where does CPUs shine in review, but also maybe some other things that are maybe not so intuitive. So CPUs have grown up and built themselves out from the very beginning, decades of kind of work here, to be very flexible. And that means you can run traditional workloads and AI workloads just like any other workload, right? So the virtualization, the Kubernetes, all of these services that are typical in cloud infrastructures like Scaleway, all run very, very nicely, and you can treat AI just like you treat any other workload. With GPUs, that's a fixed resource. and it's very, very proprietary resource. So it's something that has to be specialized. It means specialized stacks. It means limitations in many of the virtualization and clustering and kind of elastic services. So these are very, very difficult to do. So I'm going to wrap it up and say, you can start all this now by using the new CopArm instances, now with new pricing through Scaleway, and you can test all of this stuff out. Take advantage of that performance per euro that I was talking about earlier. Dedicated offerings will be coming soon, and you can get help. You can get help from us. I've got some links up here on this content for GitHub to get access to models and all these sorts of things, and also a marketplace which is built out of our consortium called the AI Platform Alliance. That consortium also has many, many different solutions at a use case level that you can put together and get help to build AI for your needs, okay? Thank you very much for your attention today, and I really, really appreciate it. It's been my honor just to talk to you today.